Hello and welcome to the Chemistry Solution. This tutorial is on Hess's law. Remember that enthalpy is a state function, and that means it depends only on the current state of the system. That means that the enthalpy change, or delta H for a reaction, depends only on the initial and final conditions and not the path taken. And so whether a given reaction occurs in one step or in many steps, the enthalpy change remains the same, and this is the basis for Hess's law. Hess's law states that the enthalpy change associated with a reaction carried out in multiple steps is equal to the sum of the enthalpy changes for each individual step. So let's look at an example. Calculate delta H for the following reaction. 2 carbon monoxide plus O2 goes to 2 carbon dioxide. And we'll calculate delta H for this reaction given the two reactions below and their delta H values. So the first step to do this is to manipulate the given equations so that they most closely resemble the equation of interest. So let's look at our first equation. In the reaction of interest, carbon monoxide is on the reactant side. And of the two equations given below, you only see carbon monoxide in one of these equations, and it's on the product side. So what we're going to need to do is to flip this equation around so that carbon monoxide is on the reactant side. So we'll write the equation below, except we'll flip it around. So here we have 2 carbon monoxide going to 2 carbon plus O2. And because we flipped this reaction, we need to flip the sign on delta H. So remember, the delta H value for a reaction written in the opposite direction is of the same magnitude but of opposite sign. And so if we flip the equation, we flip the sign on delta H. So if 2 carbon plus O2 gives us 2 CO and the delta H value is negative 221 kilojoules per mole, then 2 CO going to 2 carbon plus O2 has a delta H value of positive 221 kilojoules per mole. Looking at our reaction of interest, I see that there are 2 moles of CO2 on the product side. And when I look down at our given equations, I see only one of the equations have CO2, the second one. It is on the product side, but there's only 1 mole of CO2 in this reaction. And so for this equation, I need to multiply it by 2. So that I have 2 moles of CO2, so it more closely resembles the reaction of interest. And when I multiply the reaction by 2, I need to multiply the whole equation by 2. And I think it helps to draw parentheses around the entire equation. So this gives us 2 carbon plus 2 O2 gives us 2 CO2. And again, I want to perform the same operation on delta H as I did on the equation. So if I multiplied the equation by 2, I need to multiply the delta H value by 2. So if the reaction carbon plus O2 gives us CO2 had a delta H value of negative 393.5 kilojoules per mole, then the reaction 2 carbon plus 2 O2 gives us 2 CO2 has a delta H value of negative 787 kilojoules per mole. So here I've written my 2 new equations that I modified to more closely resemble my equation of interest. And what you're going to do now is add these 2 equations together, keeping everything on the reactant side on the reactant side, and everything on the product side on the product side. So in my new equation, I have 2CO plus 2C plus 2O2 gives me 2C plus O2 plus 2CO2. And because I added the reactions together, I'm going to add the delta H values together. So the delta H value for this equation is negative 566 kilojoules per mole. But you'll notice that I have some compounds that are the same on both the reactant side and the product side. And so anything that's the same on both sides of the reaction arrow can be canceled out. So I can cancel out my 2 moles of carbon on both the reactants and the product side. And I can also cancel out the 1 mole of O2 on the product side with 1 mole of O2 on the reactant side. leaving me with the final equation 2CO plus O2 goes to 2CO2. And the last thing you need to do is to double check that this equation matches your equation of interest. And in this case it does. So the delta H value for 2CO plus O2 goes to 2CO2 is negative 566 kilojoules per mole.